Let's create a histogram on your calculator with the number of wins. So are we okay on our buddy the Desmos? So we're going to title it whatever we want. L equals. So title L equals in this case. What comes next? I forget. What comes next? Bracket, square bracket, open square bracket. Again, this works on your phone very well. And then we wanted the win, so I got 68. Separate all these by a comma. Hello. Separate these by a comma.
Oh, I thought we were doing winning percentage, not.
Oh, what? Did I read it wrong? The number of wins each season. That's problem number one, right?
Oh, no, it's just a winning percentage.
Are you?
The second part asks like the X and X max scale.
Oh, okay. So what was it on the back? It was winning percentage. Oh, let's do that then, because that'll actually help us on the problem. All right. So 2 questions that come with this. As far as the winning percentage goes, you have 0.420, 0.4017, 0.457. So you can put the decimals in, but sometimes that gets tougher on Desmos to realize that your scale factor has to be a small fraction as well, a small decimal as well. So, so if you want, just move the decimal 3 to the right. Comma, 451, comma, 512, comma, 568, 457, 557, 552, 469, 414, 420, 457, 451, 51, 506, 444, 475, 512, comma, 512 again, 435 or 535, 453, and 414. All right. So notice I put it in as the 3-digit number. I did not include the decimal. Okay, it's still correct. If you do the decimal, what you'd have to do is you'd have to make your scale factor like 0.02. But this isn't. So then we can either type in the word histogram, or you can find histogram under functions. And it's under visualization. So histogram of L. I don't know, let's make it 50. I don't know if that's right or not, but if you hit the plus button, it takes you to your graph. Hey friends, do we have enough for our histogram on this graph with 50? No, I want 5 to 10. I only have 4. So that means I'm going to change my 50. I don't know, maybe just play around with it. Say, maybe make it 40. Hey, is that good enough for a histogram? 5 columns, that's good. Okay, and so just you would have to generate that. And again, the histogram will tell you between these 2 amounts of games, it looks like you had 4 that happened there. Between these 2 winning percentage games, we had 10. Between here, we had 2. Here, we had 5 and 2. Yeah.
What is the 40 really trying to represent here, though?
The bottom number?
Yeah.
40. Or the 40, that's just the width of these columns.
Okay.
So from here to here is 40. 40, 40. It's 40 wide.
Okay.
That's all we're changing on.
It kind of looks like 50.
Yeah, it could, yeah. So I think each one of these lines, let's see. So if I count 10, 20, 30, 40. So each of these is 10. 10, 20, 30, 40, 10, 20, 30, 40. Does that make sense? Cool. All right. So, and then number 5, maybe we can kind of look at that. It says, good idea Study the data to look for unusual features that make this data misleading. Look at 94 and 95's season, 94, 95. What are some things you see between 94 and 95? There might be more games. Is that something that sticks out to you? I mean, if you had 53 wins, 64 losses versus 77 wins and 67 losses, I think the 95 season has more games. So they might have changed something in baseball that might have done something in that.
It was the lockout year.
Well, that could have been. That could have been too. Yeah, there's all kinds of things to do. All right, let's get to page 10. Page 10 of the notes. Hey, we're on page 10 now. All right, good to see you. Page 10. All right. It's 10 at the bottom. It's after 9, before 11. Like stirrup, I know that. Just trying to point it out. So page 10. Guess what my thing is doing already? Dude, I barely started writing anything, and it goes and starts goofing up on me right away. All right. All right, so it talks about stem plots and dot plots. Okay? And this is just another way of looking at data to see if we can see any patterns to it. Again, data is not, you can't make conclusions based on data. So stem plots, sometimes they call them stem and leaf, or sometimes it might be called a dot plot. And it's just a matter of counting up. So if you look at the little scale there, it says final sale price to the nearest dollar. If I went through this stem plot, so this means I would have a price of 34, another price of 34, and another price of 35. You didn't have anything in the $40 range. You had a price of 52. If you get to the 6, you have a price of 61, 61, 62, 65, 65, 65, 65, 65. These are observations that are taking place. Okay? So let's see. This doesn't really talk about what it is that we're evaluating. It's just basically taking a look at our data. So again, so if we had, I'm not going to regenerate the whole thing. One, two, three, two. Come on. Guess what's happening? Guess I'm gonna have to teach that. It should work. All right. So basically, when you're looking at this stem and leaf diagram, do you see how I get 34 and I get a second 34? So basically, this is the first part of the number and then the last part. So 34, 34, 35. Nothing costing the $40, 52, and then I have 61, 62, 60. 61, 61, 62, 65, and I think there's 5 65s. So it's just your matter of looking at your data, put it in a numerical order. You have 72, 73, 76, 79, 89, 89, 97, 100, 104, 108. There's nothing that's in the 110 range, 120 range, 130 range, 140 range, but there's something that happened at the 150 range. So sometimes it's called the stem and leaf. The stem is the left portion. The leaf is called the right portion. And it's just a matter of looking at your data to see if I can make an observation based on this. Okay, let's try this one more time because it's frustrating. Okay, so how many prices are represented off this list? We'll count all the numbers on the right. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. There's 24 pieces of data that are on our stem leaf that we're talking about. Notice I'm not talking about the ones on the left. That's just the base of our number. Okay? What's the lowest price when you're looking at the thing? What do you think? What's the lowest price? What's the lowest price based on this? What's the smallest number I said? 34. What's the biggest? 150. Yeah. And notice as you go from 9 to 10, your stem goes from a single digit to a double digit, which is totally fine. You're just looking, your leaf is being the last number upon it. Stem and leaf include all kinds of things, stems and leaves. It does maintain the entire data set. This becomes discrete data, meaning that it's countable data. Why this is different from a histogram is because you actually know what the data is. So if I had a histogram, which was this, give me a break. If I had this might tell me that I have this many pieces of data in each of these regions. It doesn't tell me actually what the value is. But the stem plot, where we have 3, 4, 5, we had 2, 3, 6, 4, or go on order stirrup. You're smarter than this. And then 41, 1, 1, 7, 8, 51, 51, 52. So you could take that stem plot, make it vertical, and it kind of represents the same idea of a histogram. But I can find the middle of my data. I can find the mean of my data. And we haven't really talked about that yet, but that's stuff that you've probably heard about at some point. So the histogram is a visual of a range counted. The stem plot or the box plot is basically shows you where all the data actually takes place. Stem plot's great when you have a small amount of data. You know, if you had 10,000 pieces of data, it's ridiculous to try and create that list. Obviously, if you had 10,000 pieces of data, I would say, and I'm not going to give that to you, but you need to use a computer. This is nothing that you would draw by hand. Yeah. No, just itch. Okay. Histograms are more useful with very large data sets. So histograms, really big, stem and leaf when it's smaller. What's really the comfortable number? I don't know. Okay. We could sit there and say, you know, let's give an arbitrary value of 50. Would 50 be the exact amount? Well, you probably have, bless you, you might find statisticians that might argue saying, no, it's 64. And you're like, where did that even come from? Okay, stem plots show each of the outcomes. They have a clear title, so you would have the title of your stuff. Dot plot is another quantitative way of looking at data. So a dot plot looks, so again, here's our histogram. I think that's my histogram. But then I might have a dot plot. So maybe this is 10, 11, 12, 13, 14. And a dot plot again, you're getting dots. You're counting how often things are taking place. So the dot plot on page 11 says, what does each dot represent? Well, this is basically, they took a random sample of 2015 model year vehicles, and they figured out what their fuel economy was for each one. So it looks like they had one vehicle from the sample that had 16 miles per gallon. You had one at 23, one at 24, one at 27. It looks like the 31 had the most as far as their random sample went. What's the highest observation? You had a vehicle that got 40 miles per gallon. The lowest observation would have been 16 miles per gallon. Okay, so stem plots, dot plots require a smaller number of observations, but they do maintain the entire data set, which is good. So far we've talked about bar charts. So a bar chart, remember, you have titles on, here, let's just review this, make sure we're good. If you had a bar chart, big thing about the bar chart, they don't touch. The widths of each of the rectangles are the same, but these are categories down here. And then you have the histogram, and I'll just do those one after the other. Histogram, they're all the same width. Down here is a range of some sort, so it could be like 0 to 5. Oh, yeah, I almost made it. I was almost there. Okay, so, and then a circle graph. What's the important thing with a circle graph? How do you know when your data is good for a circle graph versus bad? It has to add up to 100%. Okay, so you have to be able to find the percents of each region. If each region doesn't add up to a total of 100%, it's not good. And then we talked about stem plots and dot plots. And then there's just all types of other pieces of information that I'll jump in with looking at data. But again, the hard thing about data is I can't make a conclusion based on data. Okay? Does that make sense? Like, how can I not make a conclusion? I'm looking at what the data is. I can't make a conclusion based on that. That's kind of goofy. But there are tests that you have to run in order for you to be able to start making a conclusion based on data. You have to have a random stratified sample. You have to have a certain number of the outcomes that take place. Yes, you can go find the mean, the median, the mode, the range, all of those things, which we'll look at tomorrow. But those are all things you can find. And I still can't make the conclusion based off that. I have to make conclusions based on using a p-test or a t-test. Okay, and those are just two of the tests that we'll see. There's other tests that are truly available for us. Yup. So, what I would like us to work on, you have rest period. Let's see, that was 1-5. All right, what do you think? 103, 104 sound okay? You have time to work on it right now? Perfect. And happy to come around and help you. This is supposed to be a 4. Page 103, 104. All right, let's stop that.